Hi everyone, welcome back to Data Management 3. My name is Annie Zhao, and I'm going to take you through our second video where we are grouping and summarizing data for visualization. We left off the last video having used SUM to look at how federalism has changed over time in the world. We also left off asking if we were to think about the changing prevalence of these institutions over time, should we really use SUM? Maybe not. This power sharing data we were working with dates all the way back to 1975. So from 1975 to the present, we've actually had a lot of new countries come into the system. If even a few of those new countries have these institutions, the count of them is going to go up, even if they aren't becoming more common. It's also the case that we could have a bunch of missing data back in the 70s and 80s, and this is simply because the source materials we code from are harder to find for earlier periods. We may have better data coverage in the more recent years, and that might make these institutions look more prevalent. So maybe SUM isn't the way we want to do this. Maybe we actually want to think about the mean. If we take the mean, we are scaling the SUM by the total number of countries in the world for which we have data. So if you take the mean of a dummy variable, you're going to get the proportion of the countries in the world that have this institution instead of just the raw count. That might be a better way to do it. So on line 69, we're going to create this new object called yearly proportion 1. To create it, we will run the exact same code we ran before, but we're going to just switch the SUM to a mean. Now there's always this question of what's the idea I want to communicate to my audience, and what is the best way statistic with which to do it. It's not always obvious. If we display this updated data, we can see that for sub-ed and sub-police and sub-tax, there is a slight increase, and it really hasn't changed the picture substantively. But what we have done is probably a more precise way to look at this. Now, that is a rundown of group by and summarize at. These are very useful commands, and they will help us in our visualization of data moving forward. Now we're going to work with another spec data set, the replication data from our productive pacifist paper, and was recently published in the International Studies Quarterly. We're going to load this in with the simple load command. I want to see the data object pop up on our right. That is our replication data. Let's take a look at the structure of that with the str command on line 87. So in our console, we can see there's a lot of variable names. We have, it looks like 15,599 observations and 33 variables. So before we do anything, let's ask ourselves, what do we want to do with this data? What if we want to compare some regions over time? What if we want to compare some trends in individual countries to some trends in regional averages? In this case, let's prepare to make a figure where we describe changes over time in economic structure and specifically the land orientation of the economy in Asia and Europe as regions, and in China and US in particular. To make that comparison, we're going to need two different units of analysis in the same data set, country year units and region year units. Because we want to compare what is going on in Europe and Asia in general to what is going on at the same time in the US and China specifically. To set up for this figure, we're going to need to do some collapsing by two variables, by region and by year. We don't currently have a region dummy in this productive pacifist data set that we just loaded in, so I'm going to have to merge that in to get us started. On line 90, I'm going to load in the region dummies, and we're going to be able to use those for our merge. after using our full join command on line 93. And you learn this command in data management too, but we're going to essentially merge our region data, our region dummies, to our productive pacifist data. So, as always, in the lab, when we're working with country year data, I merge by GWNO and year. Recall that GWNO is a Gleditsch war number, and it's essentially a numeric country ID code. So we have added our region dummies to the dataset at this point. Region dummies are a set of variables that take the value of either 1 or 0 for whether or not a country is in a given region. So we might have a Western Europe dummy that takes the value of 1 if a country is in Western Europe, 0 if otherwise. We're going to group by region and year here. Then we're going to use the same summarize at function that we've used before. We're going to use our continuous measure of land orientation. That's essentially the variable of interest that we are preparing as a data set. And then we'll specify that NARM equals true. So if the value for an observation is NA, then we're going to remove it before we calculate the average. We don't want to include all the regions today. In this particular figure, we want to compare the US and China. So let's kick out all the regions we don't want. We're going to use the filter command to say, let's only keep if it's equal to East Asian Pacific or if it's equal to Europe and Central Asia. Drop everything else. Now at this point, I have two problems. The first one is I'm going to need GWNO and year variables to merge by, but I don't have GWNO in this collapsed dataset anymore. And the second problem is I need my new region year data object to be classified as a data frame. Right now, this dataset is in a tibble, and it's not a data frame. So I need to deal with these issues. First, I'm going to cheat a little bit. I'm going to assign some arbitrary GWNO codes to my two regions here. I'm going to use mutate to create this new GWNO variable in my region year dataset. I'm going to use an if-else function. And I'm going to say if the region is East Asian Pacific, then I'm going to give it the Gleditsch war number of 1,000. Otherwise, I'm going to give it the Gleditsch war number of 2,000. I use these arbitrarily high 4-digit Gleditsch war numbers because Gleditsch war numbering system goes to the highest one, and that's 990. So I know 1,000 and 2,000 are not already assigned to specific countries. Let's run this block of code, and that will create dat_reg means, the regional means of objects. We now have a region year dataset with the regional averages of land orientation. And I have each region a country code. So we can kind of pretend these regions are countries when we merge these region year data to our country year data. And we can take a look at the structure of our data object. So when we summarize, it looks like we don't end up with a data frame anymore. We end up with a tibble, which is just a simplified table. To merge our region year tibble with our country year data frame, we're going to need to reclassify our tibble as a data frame. To go from a tibble to a data frame is really simple when it's already set up in the rectangular format. You just have to use the asDataFrame command, and I'm going to overwrite dat_reg means with dat_reg means, but like as a data frame. And in my environment, I still have dat_reg means as an object, but it's now a data frame instead of a tibble that allows us to use the full join command. Now we have the data ready. In the next video, we will push things a little bit further, summarizing data by region and figuring out how to wrangle data to compare countries to regions in the same plot. Thank you, and I will see you in our next Data Management 3 video. Bye.